This video is about something called Dijkstra's algorithm, and what that algorithm allows us to do is allows us to find the shortest path from one node to another in either a directed or undirected graph such as we have right here. And unlike the algorithms, the nearest neighbor and cheapest link, this will in fact give you the best path, not just approximation. The downside, though, is it's a fairly complicated algorithm to implement, which is why I have the table here to help us do so. And if I give you a question like this on the exam, I will also give you a table to use to help solve the problem. So we need to really understand this. This is still better than searching every possible path in the graph, but it's a lot of work. So what you're going to do is you're going to start out and say, okay, I know I'm starting at V1 and I want to get to V7, but I'm not going to try to go all the way there. All I'm going to try to do in this first column here is move one step. And I'm going to say, how much weight is there to get from the V1 node one step away here. Now, since I'm starting at V1, I'm not going to go back to V1, so I don't even need this first row here. But it really depends on if you want to start at V1 or something else in a given problem. Now, what I'm going to do is I'm going to say, okay, if I want to go V1 over to V2, you see I have a path right there that's a 3. So that means the weight here is 3, and the previous place I start at is V1. Similarly, V1 to V3, it would take 6, and my previous step is V1. Then I would say V1 to V4 is a 1 at V1. And then again, this first column, I'm only allowing myself to move a single step, a single edge. And if you do that, there is no way to go from V1 to V5 or V6 or V7. And if there's no way to do it, we're going to count that distance as infinity. Now, once you've completed this first column, you now know how you can go from V1 anywhere else in one step. And what you want to do is you want to decide which of these is the closest to V1, and that would be V4. It's a distance of just 1 away from V1. And what the second column is going to be is going to say, well, okay, let's suppose you start by going V1 to V4, and then if you took a second step after that shortest part, and you try to go to V2, V3, etc., we're going to see what the total distance would be. So if I went to V4, already, I've already used up 1, and if I wanted to then go to V2, I would have to go this way, and V1 plus V2, that would be 1 plus 3. If I wanted to go from V1 to V4, that's the one that's closest, and go straight to V3, well, there's no way to do that, so this would just be 1 plus infinity. Now that I've picked the fact that I'm going to V4 here, I'm never going to try to get to V4 again, because I would be wasting my time, so I'll cross that out. But if I get to V4 and I want to go to V5, there is a way to do it, where I'd have to go 1 that I already did, plus 9 there. And if I want to go from V4 to V6, I can't do it. And if I want to go to V4 to V7, I can't do it. Okay, now what am I going to do at this point? At this point, I'm going to say, okay, if I want to go from V1 to V2, I could either do it directly with a length of 3, or I could go V1 to V4, then to V2 with a total length of 4. And I want to ask myself which of those is faster. Well, that would be the direct path that only had a distance of 3, where the previous one is V1. Now, similarly, I would say I can either go from V1 to V3 for 6 direct, or infinity after going from V4. That's not good. So the 6 direct would be the best one of that choice. So I copy that down. then I would say, what if I want to go from V1 to V5? I can either do infinity or 10. 10 is going to be better, and the previous step would be at V4 there. Now if I want to go from V1 to V6, it's either infinity or infinity. Well, the smallest of those two is infinity still, and infinity, infinity, again, infinity. So basically what I'm doing is I'm saying, okay, of all these things here, I'm comparing two possible ways to get there. Either I go directly from V1 to there, or I allow myself to take two steps going through the closest V4 and then arriving there. Now once I've done this, I'm going to kind of repeat the process. I'm going to say, okay, which of these is closest? It looks like V2 is now the closest one. And if V2 is the closest one, then I'm going to say, okay, let's go from V1 to V2 direct, and then try to go everywhere else out of that. But I don't have to worry about going from V2 to V2. I have to worry about now V2 to V3. So if I first go to V2, I take 3. And if I then go to V3, it looks like, I know it's maybe hard to see now, but the arrow going between V2 and V3 is only going the opposite direction, so I can't do that. So V2 and V3 cannot go directly there, so it would be 3 plus infinity. If I get to V2 and I want to go to V5, I can do that right here with an additional cost of 5, so it would be 3 plus 5. And then, if I want to go from V2 to V6, looks like I can get there with additional cost of 2. And then finally, V2 to V7, that can't be done, so 3 plus infinity. And then, let's pick light blue here. So then I would say, okay, at this point I can either go 6 from V1 or infinity. 6 is going to be the better of the two. I can either go 10 or 8. 8 is going to be the better, and the previous one would have been coming from V2. I can do infinity or 5. 5 is going to win, coming from V2. Or infinity or infinity. It's going to be infinity there. So I get that. Then we repeat the process here. So I'll say, okay, I have 6, 8, 5, and infinity. The 5 is going to be the best. So I need to figure out where that 5 can reach. And I would say, okay, here, if I want to get to V3 here from V6, so if I'm currently at V6, I want to get to V3, I can do it with adding 0. If I'm currently at V6 and I want to get to V5, I can do that here by adding 2. If I want to get from V6 and then go to V7, I can do that by adding 7 here. And so, continuing on now, I would have, okay, either 6 or 5. 5 is going to be the best, coming from V6. Then here, 7 and 8. 7 is going to be the best, coming from V6. And infinity and 12. 12 is going to be the best, coming from V6. Almost done now. We have to decide which of the best of these here. It's going to be the 5. So get rid of that part there. We need to do 5 plus, 5 plus. And we say, okay, if I'm currently at V3 and I want to get to V5, V3 trying to get to V5 is right here. It's going to be plus 3. And if I want to go from V3 down to V7, looks like I cannot do that. So it's going to be infinity here. Almost done now. So 7 and 8 is going to be 7 from V6. 12 infinity is going to be 12 from V6. We pick our best choice here. Best choice is 7, so it's going to be 7 plus. It's coming from V5 to V6. Looks like I can do that right here. A 4, that's going to be 11. So that means 11 is going to be the shortest path. And if we want to follow that back here, let me use, say, pink here. So it says 7 plus 4, which came from V5. So from V7 back to V5. And then how did I get to V5? That was right here. The previous one was V6, it says. So that would be this way. And then previous to V6, I went from V2. So it would be this way. And finally from V2 to V1, this way. So this right here is going to be the shortest possible path from V1 to V7. And this is the Dijkstra's algorithm. As you can see, there's a lot of moving pieces here. But by the end of the day, you have the fastest way from V1, in fact, to any other possible location.